The universe is a vast and ever-changing place. From the smallest particles to the largest galaxies, everything is in motion. This cosmic dance has fascinated humans for millennia, inspiring countless myths, stories, and scientific inquiries. For centuries, humans believed in a static cosmos, an unchanging firmament above. Ancient civilizations meticulously charted the stars, believing them to be fixed points in the sky. These early astronomers created detailed star maps which were used for navigation and to mark the passage of time. However, the 20th century brought with it a revolution in our understanding of the universe. Advances in technology and new scientific theories challenged the long-held belief in a static universe. Scientists began to uncover evidence that suggested a dynamic and ever-changing cosmos. Scientists discovered that our universe is not static at all, but rather it is expanding. This was a groundbreaking revelation that changed the way we perceive the cosmos. The idea that the universe is expanding means that galaxies are moving away from each other, creating an ever-growing expanse of space. Like raisins in a rising loaf of bread, galaxies are moving apart from one another. This analogy helps us visualize the concept of an expanding universe, where space itself is stretching and carrying galaxies along with it. This groundbreaking discovery has profound implications for our understanding of the cosmos and our place within it. It suggests that the universe had a beginning, a moment of creation, and has been evolving ever since. This realization has led to new questions about the ultimate fate of the universe and our role within it. The idea of an expanding universe was first proposed in the 1920s, based on Albert Einstein's theory of general relativity. Einstein's equations suggested that the universe could not be static, and this idea was further explored by other physicists and astronomers. Edwin Hubble, an American astronomer, made groundbreaking observations that provided evidence for this expansion. Using powerful telescopes, Hubble observed distant galaxies and noticed that their light was redshifted, indicating that they were moving away from us. Hubble's observations showed that galaxies are moving away from us, and the farther away a galaxy is, the faster it is receding. This relationship between distance and velocity is now known as Hubble's law. This observation, known as Hubble's law, provided the first concrete evidence that the universe is indeed expanding. It marked a pivotal moment in the field of cosmology, opening up new avenues of research and deepening our understanding of the universe's origins and its future. One of the key pieces of evidence for an expanding universe comes from the phenomenon of redshift. This concept is fundamental to our understanding of cosmology and the nature of the universe itself. Redshift is the stretching of light waves as they travel through space. When we observe light from distant galaxies, we notice that it has shifted towards the red end of the spectrum. As the universe expands, the space between galaxies stretches, and the light waves traveling through that space are also stretched. This stretching of space itself is a direct consequence of the Big Bang and the ongoing expansion of the universe. This stretching causes the light to shift towards the red end of the electromagnetic spectrum, hence the term redshift. The more the universe expands, the more pronounced this redshift becomes. Imagine a police car siren moving away from you. As it moves away, the sound waves stretch out, making the pitch of the siren seem lower. This is known as the Doppler effect. The sound waves stretch out, making the pitch of the siren seem lower. Similarly, light waves from distant galaxies stretch as they travel through expanding space, causing a shift in their observed wavelength. In the same way, light waves from distant galaxies stretch as they travel through expanding space. This phenomenon is a crucial indicator of the universe's expansion. This makes the light appear redder. The degree of this redshift can tell us a lot about the speed and distance of these galaxies. The greater the redshift, the farther away the galaxy and the faster it is moving away from us. This relationship helps astronomers map the expansion rate of the universe. By measuring the redshift of distant galaxies, astronomers can determine their speed and distance, providing further evidence for an expanding universe. This data is essential for understanding the large-scale structure of the cosmos and the dynamics of its expansion. Another crucial piece of evidence for the expanding universe comes from the cosmic microwave background radiation, or CMB. This radiation is a form of electromagnetic radiation that fills the universe and can be detected in every direction we look. It is a relic from the early stages of the universe, providing a direct link to the past. The CMB is a faint afterglow of the Big Bang, the event that is thought to have marked the beginning of our universe. This afterglow is not visible to the naked eye but can be observed with special instruments designed to detect microwave radiation. This radiation, discovered in 1965 by Arno Penzias and Robert Wilson, provides a snapshot of the universe as it was just 380,000 years after the Big Bang. At that time, the universe had cooled enough for protons and electrons to combine and form neutral hydrogen atoms, allowing photons to travel freely. The CMB is remarkably uniform in all directions, indicating that the early universe was incredibly hot and dense. This uniformity suggests that the universe underwent a rapid expansion, known as inflation, shortly after the Big Bang. However, there are tiny fluctuations in the temperature of the CMB, which are thought to be the seeds of the large-scale structures we observe in the universe today, such as galaxies and galaxy clusters. These fluctuations provide valuable information about the distribution of matter in the early universe. The existence and properties of the CMB provide strong support for the Big Bang theory and the idea of an expanding universe. By studying the CMB, scientists can learn more about the origins, evolution, and ultimate fate of the universe, making it one of the most important discoveries in cosmology. The discovery of the expanding universe led to the development of the Big Bang theory, which describes the origin and evolution of the universe. According to the Big Bang theory, the universe began from an extremely hot, dense state about 13.8 billion years ago. Since then, the universe has been expanding and cooling. In the earliest moments after the Big Bang, the universe was a seething cauldron of elementary particles. As the universe expanded and cooled, these particles combined to form atoms, stars, and galaxies. The Big Bang theory provides a comprehensive framework for understanding the evolution of the universe from its earliest moments to the present day. The theory is supported by a wealth of observational evidence, including the redshift of distant galaxies, the cosmic microwave background radiation, and the abundance of light elements in the universe. Section 5. The mystery of dark energy. While the expansion of the universe is well established, the exact nature of this expansion remains a mystery. In the late 1990s, astronomers made a startling discovery. The expansion of the universe is accelerating. This discovery, based on observations of distant supernovae, came as a complete surprise. Scientists had expected the expansion of the universe to be slowing down due to the gravitational pull of matter. To explain the accelerating expansion, scientists have proposed the existence of a mysterious force called dark energy. Dark energy is thought to make up about 70% of the total energy density of the universe. Unlike gravity, which pulls things together, dark energy has a repulsive effect, pushing things apart. The nature of dark energy is one of the biggest mysteries in modern physics. Section 6. The Big Crunch, the Big Rip, or something else. The fate of the universe is intimately linked to the nature of dark energy. If dark energy continues to drive the accelerating expansion of the universe, then the universe will continue to expand forever. In this scenario, known as the Big Freeze, galaxies will become increasingly isolated from one another, and eventually, the stars will burn out, leaving the universe cold, dark, and empty. Another possibility is that the expansion of the universe will eventually slow down and reverse, leading to a big crunch. In this scenario, the universe will collapse in on itself, eventually reaching a state of infinite density and temperature, similar to the conditions at the Big Bang. However, current observations suggest that the Big Crunch is unlikely. Section 7. The Expanding Universe and the Fate of Humanity. The expanding universe has profound implications for the future of humanity. As the universe expands, galaxies will become increasingly distant from one another, making it more difficult for civilizations to interact or even communicate. Eventually, the accelerating expansion of the universe will isolate our galaxy from all others, effectively trapping us within our own cosmic neighborhood. However, the vastness of the universe also presents opportunities for exploration and discovery. As our technology advances, we may one day be able to travel to other star systems and even other galaxies. The expanding universe is both a challenge and an opportunity for humanity, a testament to the boundless possibilities that lie ahead. Section 8. Unraveling the Cosmos, a Journey of Discovery. The discovery of the expanding universe has revolutionized our understanding of the cosmos. It has forced us to rethink our place in the universe and has opened up new avenues of research in cosmology, astrophysics, and fundamental physics. The search for dark energy, the exploration of the early universe, and the quest to understand the ultimate fate of the cosmos are just a few of the exciting frontiers in modern science. The study of the expanding universe is a testament to the power of the scientific method. Through careful observation, rigorous analysis, and innovative thinking, scientists have been able to piece together a remarkable story of the origin and evolution of our universe. Section 9. A universe of possibilities. The universe is a vast and mysterious place full of wonders that we are only beginning to understand. The discovery of the expanding universe has opened up a new chapter in our exploration of the cosmos, revealing a universe that is far more dynamic and complex than we ever imagined. As we continue to probe the depths of space and time, we can be sure that the universe will continue to surprise and amaze us. The journey of cosmic discovery has just begun,